Okay, it's working. Today, as I promised, we continue discuss organic chemistry. We will discuss angles, bonds, and compounds with oxygen. And I try to make its lesson separately, and in this time I use better camera. So what we must to know, as probably someone here, we dealing in organic compounds with hybridization. We dealing with orbitals. We have importance, it's top shell of electrons. Importance, it's s orbitals, and p orbitals. 1 orbitals, 2 orbitals, 3 orbitals. And in these p orbitals, we have, by using these orbitals, we have several combinations of p, p, p. Sometimes all these orbitals using for compounds forming, for example, in methane, sp3. Sometimes we can use just sp2, and sometimes we use just sp. And in organic compounds, we're dealing only with sp2, sp3, and sp. Nothing more. Just this one, nothing more, nothing less. Only these 3 type of hybridization. And we have double bonds, and we're dealing with triple bonds. Electrons overlap if we have one atoms and we have another atoms, and electron overlap, we get bonds. And if we have p orbitals and it's also overlap, it's also can cause in bonds formation. But if we're dealing with bond which formed directly between atoms, we name it sigma bond. It's sigma. Or sometimes use symbol like this, sigma. Another options, it's if we're dealing with overlapping, like in alkanes, for example, we have partly overlapping, it's sigma bonds, but additionally we have pi bonds. And if we're talking about carbons compound, and not only carbons, if you're dealing with single bonds, it's also sigma. If you're dealing with double bond, it's sigma plus pi. And if you're dealing with triple bond, it's sigma and pi and pi. For modeling all these bonds, I use 3D model. It's physically quite accurate, especially for our case. Only single bond, it's sigma, and it's can rotate. Double bond, like ethane, which using for banana. Acceleration, B, sweet. and triple bond. So what we can see from double, single and triple bond, single and triple bond can rotate, double bond no. So if would be very accurate, triple bond itself can't rotate, but because if you're dealing with triple bond you have single bond, so compounds with triple bond can rotate like with single bond. Because actually if you have triple bond, it's mean with triple bond we have two double bond. If we're dealing with organic compounds. So we have three type of hybridization and three type of angles. We have SP3 most popular, SP2 in alkanes, and SP. If we are talking about angles in SP, two orbitals, we have angles 120, and we have plane structure, 109 with a half. It's if we're dealing with SP3 hybridization, and if we're talking about SP, angles will be 180. So you probably forget a lot of moment about hybridization, but what important? If you're talking about SP3 hybridization, you have only 4 single bonds with carbon. If we're talking about SP2, you have 1 double and 2 single bond. And if we're talking about SP hybridization, it's or triple bond with double bond or with single bond, or 2 double bond together. So for any questions about hybridization, for organic chemistry, you must memorize only this table: spt, sp2, sp, and these angles and this structure. So if it's hard to memorize these angles, you can just memorize all angles with bonds in organic compounds with carbon always equal. So it's equal with this, and this equal with this. So actually for prediction angles, we just memorize how many bonds. If we have 2 bonds, maximum and single and same angle, it's 180. If you have 3 bonds, maximum equal angle is 120. And with 4 bonds, it's 109 with a half. But 109 with a half, it's because we have 3-dimensional space. And in 3-dimensional space, maximum angles, it's 109 with a half, like here. It's maximum possible angles. If we look, all angles here with this carbon equal. All angles here also equal. And all angles here also equal. So it's how we're dealing with hybridization. So let's remember single bond, it's sigma always, double bond, it's sigma plus pi, and triple bond, it's sigma plus 2 pi. For example, we have a structure, condensed formula, here we have 1, 2, 3 double bonds. If we're talking about for example these compounds, any double bond it's sigma plus pi. So we have 1, 2, 3, we have 3 pi bonds. And same compounds, let's isoprene, find number of sigma bond. For sigma bond, any bonds it's sigma, and if we're talking about double bond, it's sigma plus pi. And because we're dealing with organic compound, we need to show all bonds. Because for double bonds it's enough. For this case, I will show all hydrogens, because any bonds with any atoms contain sigma bond. And let's count first all CH sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8. And let's mark some different carbon-carbon sigma bond. It's 1, 2, 3. Not bad. So we have 3 plus 7, we have 10 sigma bonds. And if we're talking about organic compounds, we have not only carbon with this, or this, or this, or these fragments. Wait. Sometimes we also dealing with oxygen. And for oxygen, we have two possible fragments. It's or like this, or like this. And with nitrogen, in 95%, so it's in everywhere except compounds where nitrogen bonded with oxygen, we dealing with nitrogen which have 3 bonds, and if it's charged, it's 4 bonds. So in organic compounds, you can't see different fragments. So any structure, if you see, you can split this structure by these fragments, nothing more. Carbon with 4 bonds, hydrogen with 1 bond, oxygen with 2 bonds, and nitrogen uncharged with 3 bonds, charged with 4 bonds. Okay, so let's find in training for empirical formula for this case. Empirical formula. For carbon, it's easy. It's 1, 2, 3. 3 times 2, it will be overall 6 in left, 6 in right, so C6. Hydrogen, 1, 2, 3, 4, 5 here, 5 and 5 here, C5, and nitrogen, 1, 2, and 2. Empirical formula of one of form glucose. Carbons, 1, 2, 3, 4, 5, 6, 6, C6, H, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Oh, something wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12 and oxygens 1, 2, 3, 4, 5, 6. O6. C6H12O6. And last one, we're dealing with ions. It's one of form of phenolphthalein. It's acid-base indicator. We have at first here, here, and here we have by 6 carbons, and in central it's 6 times 3 plus 1. It will be 90. C90. H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. O 1, 2, 3, 4, and charge 2 minus. These compounds have formula C90, H12, O4, 2 minus. So today we discuss this. We discuss compounds with oxygen and nitrogen. We discuss angles. What most important? It's this table. You must just memorize it. If you memorize it, you can answer on 2 types of questions. It's angles, hybridization, and fragments you can draw. And all these fragments, in all available fragments for organic compounds, it's this one. And today it's all what I planning to tell you. Next lesson, I will teach you EUPAC nomenclature. And for this lesson also no needs to be prepared. So thank for watching, subscribe, join my groups. If you message me, I will be pleased.